Hello, IM3 students. Today we're going to begin a new module, Module 10, which is working with simple quadratic and cubic functions. To begin with, I hope that you've had a chance to watch the real-world video, which connects the real world with math. So hopefully you had a chance to see the video already. And today we will be using the graphing calculator. So make sure that you either have a graphing calculator or that you have logged into decimals.com so that you can follow along the lesson. And here we go with 10.1, day 1, which is finding the inverse of simple quadratic and cubic functions. So you will be able to identify the inverse functions for quadratic functions today. We're only going to be working with quadratics today. And so let's take a look at the review of the inverse idea. And for this part of it, you do not need to copy the notes, so just follow along in the video and just understand as we review the idea of an inverse. So the inverse of a many-to-one function, remember a many-to-one function is when the output is repeated more than once, right? So here we have the 4 and the 1 repeated. And so let's take a look at what the inverse of that looks like. So the reverse, to find the inverse function of a relation, we just simply reverse the x and the y coordinate, the input and output. So we will have 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So these are the new coordinates that makes up the inverse of the inverse function. So now we're going to answer the next question. Is the inverse also a function? And so let's recall the idea of a function. Remember, a function is defined when no input is repeated. But if you take a look at 4 in the input, it's repeated. 1 is repeated. So the next note says, if the answer is yes, then you do not need to restrict the domain. So to restrict the domain is needed when the answer is no. So if you do have a repeat. So is this a function? Let's answer the question, is this a function? No, and the reason is because the input are repeated. Inputs are repeated, right? In this case, the 4, again, and the 1 are both repeated. So therefore, we don't have a function. So the inverse of a many-to-one is not a function again. So if the answer is no, then we need to restrict domain in order for the function to have an inverse function. So what ordered pairs define the inverse function? So if you take a look at both of the two pairs in the front are repeated, if we just cut it right here, then we don't have any more repeated if we just cut it off and use only the last 3. So if we only use 0, 0, 1, 1, and 4, 2, then that would be constituting the inverse function. So what does that actually connect to? If you guys would connect those points, what does it look like? That would look like a 0, 0, 1, 1, and a 4, 2. So this is actually the graph of the square root function, everyone. So can you guys take a guess what points the original graphs formed? I hope you guessed it right. It's actually the x squared function, the parabola. So let's take a look at the quadratic functions. So here is the parent function, which is the original pair of 5 points. And as you can see, this is a many-to-one function because the y coordinates are repeated. So therefore, the x squared function is a many-to-one function. But we must restrict the domain because we just showed earlier that if we switch it, the input and the output, the inverse is not going to be a function. So we must restrict it. And so we can only take the positive piece right here and turn it into the square root function. So this is what it looks like. Remember, if you just reflect it across the line y equals x, and this is the original reflection of the x squared function. So as you can see, this would not pass the vertical line test. This is why we keep saying this inverse is not a function the way it is. So we must restrict it to only part of the function, which is like looking at the top part or the bottom part. So right now we have the square root of x function. So now this is the inverse. And so that's why we have concluded that x squared and square root of x are inverses of each other. So remember that the inverse, to undo the x squared, we take the square root, right? To undo it, to make it x. So that's why x squared and square root are inverses of each other. And let's take a look at the next scenario. what are the two cases to restrict the domain? So if you take the y equals x square function and you only take the right hand piece, which means when x is greater than or equal to 0, that's when x is greater than, right? That's the positive side. This is the negative side. So if you only take the positive side, then the graph looks like this. That's the original right here. And then it is reflected across this line, y equals x. And if we reflect it, then the mirror image would look like the blue one, which is this one. This is the square root of x function. So that's the inverse for the positive side. Now, if you look at the negative side, which means to the left-hand side, so if we look at the left-hand side of the graph, only this side right here, going to the left side, then this is what the graph looks like, the x squared function. And here is the same line, y equals x. And then if we reflect it, then this is the inverse, which we call, in this case, what does it look like? It looks like it's the original right here, flipped across the x-axis, right? So it's now looking over here. And so therefore, this is actually the negative x squared function. So a positive square root of x looks like this, and a negative square root of x looks like this. So it actually makes sense. So the left side of the x squared function reflected looks like it is the negative square root of x. So that's how you get these square root functions. So we're going to try some problems now dealing with the square root functions, and actually we're going to start with the inverse of that, which is the square function, the quadratic, and then we're going to obtain the inverse, which is a square root function, and then confirm that using the graph. Okay, so here we go. We're going to start by finding the inverse of the function first. So the original is f of x equals 10x squared. So remember the steps of finding the inverse, right? First step is to change that f of x to y. Next is to interchange the x and the y. Next, we're going to solve for the new y. So we're going to divide it by 10. And then we got y squared equals x over 10. And then finally, we're going to take the square root of both sides, right, to get rid of that square. So now we're going to switch the y to f inverse of x equals, and then we have square root of x over 10. Now, I need you guys to do something with your regular calculator. If you can try, actually. So now we know the inverse of x squared is square root, right? I want you guys to try taking the square root of -4 and see what you get. Go ahead and try it. Pause the video and try it. How about what did you get for the answer? You should have gotten something like E or error, right? It kind of broke your calculator. And how about try -9 or -8 or just any negative? In fact, any negative number you put inside the square root is going to give you error message. That is because we cannot take the square root of a negative number, guys. So that's why we need to restrict the domain, the x values for the square root function, to only positive numbers. So if you try taking square root of 0, you actually get 0, right? So 0 is the smallest number you can put inside. So we're going to actually restrict the domain. So whatever is inside the parentheses, the radicals, which means x over 10, it needs to be greater than or equal to 0. That's the absolute smallest, 0, right? And we're going to solve for x. So multiplying by 10 on both sides will help you get rid of the 10. So we got x is greater than or equal to 0. So our domain, and this is how we're going to write it, the domain is x such that x is greater than or equal to 0. And that's the domain that you must restrict for any square root functions, because we cannot take the square root of a negative number and just, so that's why we need to restrict it. But now we're going to confirm that we found the correct inverse. Well, how do we know this is the correct inverse? Well, remember in the previous lessons, we already learned how to verify, right? Finding the inverse. So we're going to go f inverse of f of x and see if we get what back? X, right? So f inverse, we're going to start with square root of x over 10. What do we put inside the parentheses? We put f of x. F of x is at 10x squared. And we're going to simplify by crossing out the 10, and that leaves you square root of x squared. The x squared and x will, the square root will cancel out, and you get x back. So we're one way already. We're going to go backwards. F of f inverse of x to make sure that we verify both ways. So the f of x is 10, and then that's x squared. What do we put inside these parentheses? We will put inverse, which is square root of x over 10. And now we're going to undo this. The square root and the square cancels out, and the tens will cross out, so you get x by itself. So now we have x back in both. We have verified that this is the correct inverse. In fact, you can go ahead and go into decimals right now and enter the equations. I put the original, the inverse that we found, and the line y equals x just to show that this is the mirror. And so this is your 10x squared right here, and this is your square root of x over 10, and to show that they are a reflection of each other. And that's how you can verify. So go ahead and use decimals to verify before we move on. And now we're ready to try another problem. So here's another quadratic function, and we're going to actually do the same thing that we just did. We're going to find the inverse, restrict the domain, confirm that's the inverse, and then show it in a graph. So we're going to start by finding the inverse. So y equals x squared minus 6. Next, we're going to interchange the x and the y, and then solve for the new y. So adding 6 to both sides, so we got y squared equals x plus 6. Taking the square root of both sides, we have y equals square root of x plus 6. And then we're going to rewrite it as f inverse of x equals square root of x plus 6. Again, we need to restrict the domain because we cannot have anything negative under the brackets, the quadratics. We're going to restrict the domain to x plus 6 must be greater than or equal to 0. Solving for x, we have x is greater than or equal to negative 6. And if you actually substitute negative 6 back in here, you're going to get 0. Square root of 0 gives you zeros. That's the minimum you have. So that's why x must be greater than. So the domain is actually x such that x must be greater than or equal to negative 6. And that's the domain that we need to restrict. So we got the inverse going, and we got the restriction for the domain. Next, we're going to verify to see that we have found the correct inverse right here. So we're going to actually verify. So we're going to go f inverse of f of x is equal to square root of x plus 6. And what do we put inside the parentheses? We put f of x, right? So f of x is x squared minus 6. And we're going to cross out the 6. And then we got square root of x squared, which crosses out the x squared and the x. That leaves us x. So we're one way there. We're going to go backwards by taking f of f inverse of x. And so f of x is x squared minus 6. And what do we put inside the parentheses? We put f inverse. And the inverse is x square root of x plus 6. The square and the square root cancels out. That leaves us x plus 6 minus 6 equal to, the 6 will cancel out. We got x by itself. So that's how we, in fact, verify that those are the inverses of each other. So we're going to put the original function and the inverse into decimals and verify that that is a mirror image. And so there we have the mirror image, and hopefully you can verify that as well right now. Go ahead and go to decimal because you need to practice this, entering the graph and the function and the inverse. And here we go. You are ready to try one on your own. Go ahead and try the problem from beginning to end, just like we did. I've already shown you twice how to do this, and it's time for you to practice. So try it before you look at the answer, and then verify with decimals first. So hopefully you've had a chance to try it. Again, we're going to start with the function and finding the inverse. Switch the x and the y, and we're going to solve for the new y. So y squared equals x over 3, taking the square root of both sides. I have x equals square root of x over 3. Again, we need to restrict this domain, so we got x over 3 is greater than or equal to 0. Multiplying 3 to get rid of the 3 in the bottom, we got x is greater than or equal to 0. So we restrict the domain to x such that x is greater than or equal to 0. That would be our domain restriction here. And we're going to verify that we have the correct inverse. Actually, we need to finish here. So it's f inverse of x is equal to square root of x over 3. So we're going to verify that that is correct. So we're going to start with f inverse of f of x is equal to square root of x over 3. And what do we put inside the parentheses? We put f of x. That's 3x squared, right? Cross out the 3's, and you got square root of x squared, and that leaves you x. And we're halfway there. So we're going to go f of f inverse of x, which means we're going to start with f, which is 3x squared. And what do we put inside the parentheses? We put f inverse, which is square root of x over 3. The square and the square root cancels out. We got 3's cancel out. We got x by itself, and that's how we verify that the inverse is correct. Now, once you verify, go ahead and enter the function and the inverse into decimals, and then just to double check that that is a mirror image of the inverse, and that's how we can verify. And it looks like we have come to the end of day 1, so go ahead and get started with your assignment in Google Classroom, and see you tomorrow. Have a nice day.